Hello everyone, today's video we'll be looking at exercise 5G, which is the applications of quadratics. Okay? So really quickly in this exercise we'll look at solving application style questions. These skills are exactly the same as we've learned so far, but now we just apply them to worded style questions. Okay? The maths is no different. We have been doing the topic of quadratics. All the maths within these questions is quadratics. The only new part or new step realistically in the whole grand scheme of things is finding the quadratic in the problem. Okay, it's just described in words. We just have to draw out the quadratic. Once we've drawn out the quadratic, it's as simple as factorising and solving like we've done in the previous sections. So some steps that will help us do that. One, define your variables, okay? And you have to do this. We will look for it. It's your working, it's being rigorous in mathematics. You need to do it. It's just like you start the sentence with a full stop in English. In worded problems, application style questions, you define your variables. If they are not defined for you, you must define them yourself. Once you've defined them, you should then be able to write an equation using them. Okay? This is just like what we did with the simultaneous equations chapter. Okay, it's now just going to be quadratic. We're looking to form a quadratic equation. Okay, you then solve it using whatever tools you have. It may be factorizing then the null factor law, it could be simple algebraic manipulation, whatever it is, but it's likely going to be some form of factorization since we're doing the quadratic section. And then step 4, choose the appropriate solution. Go back, look at your problem and figure out which, because we're generally with quadratics, we're going to have two solutions. Generally, one of them will be applicable to our question and one of them might not be. Like we might be figuring out the distance traveled and one of the solutions is -60, the other solution is +40. Well, you can't have gone on a trip that was -60 kilometers in length, so you would rule that one out and say that your correct solution is the +40 kilometers. So the best way to do these, okay, and I think the best way to teach these is to just show you a couple of examples. Okay, and you'll see the 4 steps being used. So let's do the first one. Okay. So example 1, find the height and base lengths of a triangle that has an area of 42 centimeters squared and a height of 5 centimeters more than its base. Okay. And step A here, we're going to actually draw a triangle, okay? Especially any of these geometric problems, pretty much any word one, drawing a picture will be really helpful. So let's do that. Let's draw our triangle. Okay, and we'll let b equal to a base. Okay, we're going to define our variables. Okay, we're going to let height equal to our height. Okay, so we can draw that in h. Okay, and we have base. Now quickly, we have area is equal to 42 centimeters squared, and we also know height is 5 centimeters more than base, so I can write height as base plus 5. So part B, write an equation and solve stating the base and height length of the triangle. Okay, so we know area of a triangle is equal to half base times height, and then we can turn this into, using substituting the values we know, we can get 42 equals half by base plus 5. Okay. We will then get, I'm going to actually multiply the 2 across instead of dealing with a half on that side. We get, and then use the distributive law, we get b squared plus 5b. And then we get b squared plus 5b minus 84 equals 0. Now, I'll be honest, I had to, before running this video, I went ahead and actually looked at what are some of the factors of 84. So we have 7 by 12 may work. We have 42 by 2, 14 by 6, 21 by 4. There are a whole bunch of factors of 84. We need to get a 5. And so happens to be the one that we actually probably might know off the top of our head, which is 7 times 12. So if we had a positive 12 times by -7 gives us -84. Positive 12 take away 7 gives us 5. So that's going to work. So we're going to come up over here and we'll write b minus 7, b plus 12 equals 0. So now we've factorized, we can use the null factor law, so we can state therefore, and just to do it in full, if you haven't seen the last video, we get b minus 7 equals 0, or b plus 12 equals 0. So it follows on that b is equal to 7 or b is equal to negative 12. Now this goes back to step 4. Choose your appropriate solution. Can we have a base of negative 12? No, we cannot. So that means, okay, this is the correct one. That is not a valid solution. So we say base equals 7, and then our height is equal to 7 plus 5 is equal to 12. Come up here, and for a worded question, we write our solution in words. So the base is 7 centimeters long and height is 12 centimeters. We got asked a worded question, we answer it in words. So there's our first example. We used all our steps. Step 2, the product of two consecutive odd positive numbers is 63. So that's saying we're going to get two random numbers. Let's call let m equal number 1 and n equal number 2. Okay? And they're going to be in a row and they're going to be odd. So it might be taking 13 and 15. It might be 5 and 7. What is, we need two of them that are in a row that multiply to give us 63. Now the thing about n is going to always be m plus 2. They are consecutive odd numbers. So we know, we're told the product, so m times n equals 63. We can write that as m plus 2 equals 63. We get m squared plus 2m minus 63 equals 0. We can factorize this via inspection. Okay, multiply to give me negative 63, add to give me 2. Factor 63 should jump off is 9 and 7. We have a positive 9 by a negative 7. That's going to work. So I get plus 9 minus 7. Therefore, m equals negative 9 or it equals 7. Now it says it needs to be odd positive numbers. So we can rule out 9 is not allowed. So it follows on m equals 7. Therefore, n equals 7 plus 2 equals 9. And we know 7 times 9 is 63. So that works. So got asked a worded question. Answer our question in words. So the two numbers are 7 and done. Tick. Lovely. Now, one more example. This one's a little bit harder, and I'm going to throw it out there straight in advance, is because we end up with a sort of hidden quadratic. One of those quadratics where we've got to rearrange our equation a bit more to actually draw out the quadratic equation, then be able to factorize. A rectangular block of land has a perimeter of 40 meters and an area of 84 meters squared. Firstly, find a quadratic function to represent the information, and then solve to find the dimensions of the block of land. So we've got some block of land, okay, and it has a P of 40 meters and it has an area of 84 meters squared. Okay, and we're going to have some width and length A and B. So I'm going to let A equal width, B equal length. Okay. We know the perimeter of a rectangle is equal to 2a plus 2b, and we know the area is equal to a times b. So we get 40 equals 2a plus 2b, and we get 84 equals a times b. I'm going to rearrange this to make a the subject, so I get a equals 84 on b, and this is sort of like that simultaneous equation stuff we're doing. I'm going to call this 1, I'm going to call this 2. I'm going to come down over here now, and I'm going to 2 into 1. put 2 into 1. So we get 40 equals 2. And then instead of A, I can now put in 84 on B plus 2B. Okay. Now I'm going to take out a common, divide this side by 2. I'm going to move these 2's instead of getting a massive number for my numerator. I'm going to divide both sides by 2, so that leaves me to 20 equals 84 on B plus B. Like, okay, got a B, we've got to divide by B. We don't have any B squared. What's going on? How do I get my quadratic? And this is where it's a little bit harder. Okay. What I'm going to do is I'm going to multiply both sides by B. Times by B times by B. Okay. And when I do that, I get 20B equals B on top with B on bottom cancels 84 B squared, and then turn this into B squared. Raise that. B squared minus 20B plus 84 equals 0. There we go. We now have a quadratic. That's all that work was, just to get the quadratic. We haven't factorized it yet. We haven't solved it yet. Okay. So let's get going with that. Okay. Has a coefficient of 1, so that means we'll try inspection. So B bracket equals 0. 84, we said factors on the last page. Where was it here? 7 times 12, 42 times 2, 14, 6, 21, and 4. And we need a 20. Let's go back. A 14 and a 6. 14 plus 6 will give me a 20. So we just need to use the right numbers. That's going to be a negative 14, a negative 6. So therefore, B equals 14 or it equals 6. It follows on. Then if we use B equals 14, A will be equal to 6, or A will be equal to, in this case, if B is 6, A will be equal to 14. So now to answer in words, okay, on the dimension block land, the length is 14 or 6, and the width is 6 or 14 respectively. And that's how we do that. And yes, that's the last application one. Okay, so just to go back and do a quick review, okay, and just to clarify, actually, before I do this, done that too quickly, this is 2 sets of solutions. Okay, so what we end up with is either A equals 6, B equals 14, or we get A equals 14, B equals 6. So we have 2 set solutions, and that's what this worded answer over here. And you can try that. You can put the 2 numbers in and check your perimeter, check your area, and it will work out. So to go back and review the steps, define your variables, okay? Let B equal base, H equals height. If you're not given your variables, you must define them. You want to be clear, you want to be rigorous. It avoids mistakes. Write your equations, okay, and then start solving them. Now, some of them, the quadratic's going to come out pretty easy, but in this case, we ended up with simultaneous equations that we had to substitute in. We then had a hidden quadratic. We had to multiply both sides by B, and that finally gave us our quadratic here. Once we have that quadratic, we solve it, and then we check our solutions for ones that are appropriate. In this case, we couldn't have a negative base. In this case, we couldn't have a negative number because it said we were odd positive integers, so we discarded them and used our other one. In this case, though, both solutions were valid, so we had to use, and you have to state both. You can't just take one. If both are valid, you have to state both. That is it. If you have any questions, stick them up on the Edmodo page or below in the comments. Thank you very much.